Guys, welcome back to Teddy Talks. I'm Landers, taking you through physics. Today we are going to look at scalars and vectors. Now, straight to the point, we shall begin with what we call scalar quantities. Scalar quantities. So, what is a scalar quantity? A scalar quantity is a physical quantity which only has magnitude. Okay? We are saying that a scalar is a physical quantity that is only specified by magnitude. Or we can say it is a quantity that is described by only magnitude. So we can write that a scalar quantity is a quantity that is only described by magnitude. Okay? If you get a quantity that only has magnitude and then no direction, just know you're dealing with a scalar. Examples of scalars, e.g., we have mass, we have time. Now when you look at these, they do not have a specific direction in which they act. We also have temperature. We also have distance. We have speed. These are all scalar quantities. Good. Now, having looked at scalar quantities, let us look at the so-called vector quantities. What is a vector quantity? A vector quantity is a quantity that has both magnitude and direction. We are saying that a vector quantity is a quantity that can be described by both magnitude and direction. So we can write that this is a quantity. This is a quantity that can be specified by both can be described. Let's not say specified. Can be described by both magnitude and direction. That is what we call a vector. A vector has both magnitude and direction. It is always specific in its point of action. So examples of vector quantities, we have things like velocity, we have things like weight, we have things like force. Of course, force and weight, you realize that they're almost the same. We have things like displacement, acceleration, momentum, and many others. Anything, any physical quantity, anything that is measurable, that has got a direction, that acts in a given direction, then we say that that is a vector quantity. Now, let's look at another thing. Here, we are going to look at what we call addition and subtraction of vectors. Addition and subtraction of vectors. Now, what happens when we are adding or subtracting vectors, assuming I have two vectors A and B. Now, we are saying that a vector is described by both magnitude and direction. Now, this is what happens. For us to add or subtract vectors, when do we add and when do we subtract? One, we say that we add the vectors if they are acting in the same direction. There we add them. Okay? Then when do we subtract vectors? We subtract vectors when they are acting a different directions. When they are acting in different direction, we subtract the vectors. Now, what name do we give to the answer that we get either after adding or subtracting vectors? We get what we call a resultant vector. We come to what we call a resultant vector. So, what is a resultant vector? A resultant vector is a single vector that has the same effect, as two or more vectors. That's what we call a resultant vector. We are saying that a resultant vector is a single vector that has the same effect as two or more vectors. So guys, having looked at this about vectors, and now allow me stop here and we look at more application of the knowledge we have gathered.